All right, this is lesson 12.1, tangent lines. Now don't panic, this is not the same tangent that we used in trig. Something completely different. So, a tangent line. A tangent line it talks about the relationship between how it touches a circle. A tangent is a line that touches a circle at one point. Okay, so a tangent to a circle is a line in the place of a circle that intersects a circle in exactly one place. The point where a circle and tangent intersects is called the point of tangency. So a tangent line is a line that bumps up to a circle, touches it, doesn't cross it, so that it only touches the circle in one spot. And it has only one point of intersection, which is that point of tangency. Now, theorem 12.1 says that if a line is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. Now, that could also mean the diameter as well. So if AB is tangent to circle O at P, then AB is perpendicular to OP. So this line, the tangent line, would be perpendicular to the radius. So let's look at example 1, finding angle measures. The directions tells us that ML and MN are tangent to circle O. What is the value of X? Okay, so as we look at this, if they tell us that something is tangent and this is the radius here, then therefore this is a right angle. And so is this. So there are two ways to work this problem, and I'm going to show you both ways. We know that this has four sides, which means that sum of the angles of a four-sided polygon or a quadrilateral is going to be 360. So we could take 90 plus 90 plus 117 plus x is equal to 360. So once again, after my Moby starts to work here, so we have 90 and 90 plus the 117 plus x equals 360. So we add these three numbers up in our calculator, and that gives us 297 plus x equals 360. Subtract from 297, and x is equal to 63. Now, another way to do this is if we realize that these are both 90, which added together is 180, which is half of 360, that means that these two would also be supplementary. So we could find x by taking 180 minus 117, too many ones, and that gives us 63 as well. So two ways to work the problem. You can add them all up, or some of you will choose to recognize that these are going to equal 180, so therefore your answer would be just 180 minus 117 to be 63. So let's look at the next one. Let's find the value of x. ED is tangent to circle O. What is the value of x? Well, if it's tangent to it, that means this is going to be a right angle. So we have a right triangle. And once again, if we have we have the right angle, we have one other angle, that means we can subtract from 90 to get x. So x is equal to 90 minus 38, which leaves us where x is equal to 52. Now, if any time in these lessons that you miss something, you can always go back and take a look at it, rewind it. You can pause it, work it out yourself, and then see how you do. So let's take a look at the next part, finding distance, an application problem. What is the distance to the horizon that a person can see on a clear day from an airplane 2 miles above the Earth if the Earth's radius is about 4,000 miles? So This one can be kind of hard to see. You did see this back when we did chapter 8. We had a problem similar to this. So I'm going to redraw it here so you can see what we are looking at. So we start off with a circle. Now, then I'm going to draw a line from the center to just above the Earth's surface. Well, this is going to represent the 2 miles right here that the airplane is above the Earth's surface. And then we're going to draw a line as best as possible that would be tangent to the circle, which means it's going to touch at one spot. And then I'm going to connect that point of tangency with the radius. Now this will give us a tangent line to a circle here, which means we have a right triangle. So the next part I'm going to fill in is this distance from here to here is 2, from here all the way to the Earth surface. The radius, they tell us, is about 4,000 miles. We're looking to see how far can we see on a clear day, which would be x. Now the distance from here to here is also the radius, so that's also going to be 4,000 miles. So our hypotenuse is going to be the entire distance of 4,000 plus 2, which is going to be 4,002 miles. So next, we have 2 sides of a right triangle, and we're trying to find the third side. So what do we use to find that? That's right, Pythagorean theorem. X squared plus 4,000 squared is equal to 4,002 squared. Now once again, when we work with large numbers, it can be easiest if we just do our operations before we calculate anything. So we're going to subtract 4,000 squared from both sides. Once again, let me remind you, this is 4,000 squared, so that it's not going to be the difference of 2 squared. Okay, so we get x squared is equal to 4,002 squared minus 4,000 squared. So we'll get our calculator out, and we will take 4,002 squared minus 4,000 squared, which gives us a difference of 16,004. So this distance is going to be 16,004. So we take the square root of both sides. And to continue this, we'll go back to our calculator and take the square root of our previous answer. And that gives me 126.5. So approximately how far this, and we will round to the nearest whole number. And we'll say the nearest mile. And so this is going to be 126.5069. So that's going to be about 127 miles that you should be able to see from an airplane when you are 2 miles above the Earth's surface. All right, pause the video, and I want you guys to try part B. All right, let's see how you did. Once again, this problem is going to look very similar to the other one. So we'll start off drawing our circle. So we have the CN Tower in Toronto, Canada. Has an observation deck of 447 meters above ground level. About how far is it from the observation deck to the horizon if the Earth's radius is about 6,400 kilometers? Now, one thing I do want you to notice here is that as I draw this, and before we put our units in, I want you to notice that they give us the Earth radius is 6,400 kilometers or kilometers. And they give us the height of the tower is 447 meters. So this right here is our 447 meters. So in order to work this problem correctly, we need to make sure we convert into the same units. Now most of the time I would say convert into the smaller unit. But since we're in metric units and it's just as easy to convert to the larger unit, let's convert into kilometers. So in order to do this, we're going to say that 447 meters is equal to blank number of kilometers. So once again, meters, we're going to move it to the left 3 places. You can do your King Henry died by drinking chocolate milk. And that'll tell you you're going to go from the meters to the kilometers by moving 4 places to the left. So that gives us 0.447 kilometers. So this right here, once again, is going to be our x value, and this is going to be 6,400 kilometers. So we have x squared plus 6,400 squared is equal to, when we add these two together, we're going to get 6,400.447 kilometers squared. So once again, we're using Pythagorean theorem. So once again, we'll use, because these numbers are large, we're just going to go ahead and subtract 6,400 squared from both sides. And the rest we'll do in our calculator. So 6,400.447 squared minus 6,400 squared gives us a difference of 5,721.799,809. And our next step, so this gives us this answer here. So 5,721, or excuse me, 21 point, what was that, 9, 7,998. Okay. Oh, looks like this thing's acting up again. So 0.7998. Well, this is really having fun today. Gotta love technology. And so we're going to take the square root. This is an approximate answer here, because we're going to do the work on our calculator. We'll get an exact answer. So now we'll go back to the calculator and take the square root of our previous answer, and that gives us 75.64. So we're going to round to the nearest, we'll go to the nearest whole number again. So we're going to say this is about 76 kilometers. All right, that concludes part 1. Go to part 2 to get the second half of the notes.